The Typhoon was a beast of an aircraft. 25% larger than any other single-seater, it could also fly faster than any other fighter aircraft of the day, Allied or Axis. A 24-cylinder, 37-liter monster was the first piston engine to produce over 2,000 horsepower. The punch of a Typhoon's cannons could knock over rail cars and burst open speeding locomotives like pop cans. Yet despite its notoriety and exceptional contribution to the war effort, not one airworthy example of this venerable aircraft exists today. But one man is in the process of changing that. Ian Slater is founder of Typhoon Legacy with the goal of restoring an airworthy example of the famous Hawker Typhoon. Welcome back to Typhoon Legacy Podcast. I'm Brad Hodson and I'm here with Ian Slater of Typhoon Legacy. Welcome, Ian.
Thanks, Brad.
Today we're going to talk about fixtures and jigs, and in particular how it pertains to the fuselage rebuild of JP843. Can you tell us a bit about that, Ian?
It's a big subject. There's actually, we've done a lot of tooling work, and this is going back into the development of the program to rebuild a Typhoon as well. So in addition to all of the components that you need and the information that you need to produce those components, you also need to produce the tooling and the fixtures to support them or produce individual parts. So we've got a couple big ones here. Obviously, the largest one that we're focused on right now is the monocoque section. And I'll touch on that in greater detail. We also have one that we produced for the radiator fairing, which is another major assembly of the Typhoon, although it's just cowling. It's a pretty sophisticated piece of structure with a lot of shape to it. And the fixture for that was very important to us. So we've produced that. And the cockpit fixture is essentially at this point, it's just a table. So we've got this 6,000 pound steel T-slot table that's going to be the foundation of the fixture for holding the cockpit structure and those very crucial wing connection points in absolute perfect position. And one other small one that we've got in here is just a generic fixture that we did. It's basically a frame that stands there and it can be modified for all of our flight control surfaces. So it's large enough for all of them, but it can be kind of bisected or cut down into smaller rigid areas for smaller assemblies like our fin here. The monocoque is definitely the most sophisticated one that we've done to date. And it's the key with that is the way that the Typhoon was built. It was originally built in quarter sections. So if you look at the fuselage on the Typhoon from behind the cockpit to just in front of the tail, there's a top quarter, a bottom quarter, and two side quarters. Hawker did this to maximize the amount of people that could work on one assembly at the same time. So they actually had, for that, 4 fixtures for those components and a 5th and final fixture for the assembly of those 4 components. And that, it's excellent. It made sure that they could produce them very quickly, but it's not practical for a company like Typhoon Legacy who's building one, with the potential to do others, I suppose, because our fixtures are all reusable. So to build 5 fixtures or one, we chose to build one. It just made more sense, but it's still being produced in the exact same fashion in quarter sections and just assembled in the same fixture. So part of this is that a lot of aircraft, the Spitfire is a good example. It has more longerons that are connected to the frame. So like a stringer section that's connected to the frame, and when they're connected, they support the frame in their location and the stringer in its location. The Typhoon stringers actually run through the frames with the exception of each extreme end and don't connect to anything. So the frames needed to be supported in space by the fixture in every frame location. So it was a bit of a trick. We also had to make sure that when the airframe is assembled around the fixture, that we can actually go inside and remove the fixture from the airframe. And this is a 12-foot piece of assembly that's basically a tube. So it's very difficult to be able to go in there and pull out individual components. So the amount of design work that went into this, my father, Bruce Slater, did the design on this, and he was very, very careful to make sure that we could go one by one and remove components, that we could go in there and we'd have room for tooling for both the drilling and riveting operations. They require different tools, and we need access to the outside and the inside of holes in every case. So there's a lot of thought put into the design work that went into this, and it's worked really well. I suppose one of the drawbacks with it, it's a big plus for it, but a drawback as well, is that it's built with so many different areas for adjustment. We didn't just take this and weld it together in the position. First, I won't get into the welding. Welding isn't a great idea for it because you end up with warping and it would be very tricky to control it. We've got mechanical adjustments, screw thread adjustments, and lots of them for every frame. And it made for a very accurate assembly as we move forwards, but it was very difficult for me to dial it in.
Well, for sure. So explain to me a little bit. The predecessor to the Typhoon was the Hurricane, and it was unique in the fact that the front part of the aircraft was actually all metal, and then aft of, I believe, the cockpit was all wood. So it wasn't really a monocoque frame, was it?
Well, it wasn't wood after the cockpit. It had a wooden fairing behind the cockpit, but it was still tubular structure. And the tubular structure is a Hawker recipe that they'd been using for many aircraft, their biplanes, through the Hurricane, through into the Typhoon, and finally into the Tempest before they went full monocoque. So the tubular structure used in the Typhoon was isolated to the cockpit, where the Hurricane used it for the entire fuselage section right through to the tail.
And there were teething problems with, well, many teething problems with Typhoon. Let's talk a bit about the fuselage teething problems. So do you think because they were transitioning from the tubular to the monocoque that they didn't quite have all the information they needed to build a monocoque on Typhoon? Because as we know, we had some tail failures on that, and there were some problems early on.
It's interesting. I give full credit to the designers at the time that were doing this, but we also have to remember that if you're familiar with the de Havilland Comet, they first pressurized airliner, they put square windows in and it caused failures. Well, you don't use square windows in a pressurized structure, which is common knowledge now, but it wasn't then. In working on this airframe, I've seen it a lot in disassembling our wing section. I see it in the design of the monocoque. There's things that I definitely wouldn't build into a design now. And I think they struggle a little bit with the rivet pitches. The rivet types, again, were different with the Typhoon than the Spitfire, for example. The Spitfire used a lot of magnesium rivets. The Typhoon used heat-treated rivets all the time. And just some understanding of how to do those, the bearing strength of the materials as opposed to the strength of the fasteners. I think they were still developing it. The Typhoon was the first attempt at a monocoque by Hawker. So it really combined the two technologies together for the first time in a production sense. So talking about rivet pitches and bearing strength, one thing that I've noted in a lot of the crashed components is that because of the very strong rivets that they use for this and the relatively soft material for skins and structure, they're bearing failures, which means the material failed around the fastener. And typically what you want the fasteners to fail around the material or fail within the material. So it didn't do that. And the crash structure that I see is a lot of these bearing failures caused by stronger rivets than the structure around them. So interesting things to see, interesting things to learn. And they were definitely learning as they did this.
And do you think there was much sharing between, say, Supermarine and Hawker at this time? Because it seemed like, Supermarine didn't seem to have structural failures with their Spitfire early on.
I don't know. I don't look into Spitfires. I've got a little bit of animosity towards Spitfires because they're so popular. Beautiful airplane, but come on, guys, let's talk Typhoons. The Spitfire was definitely built completely differently, and I mean, people say that with the Merlin too. Well, the Merlin was such a reliable. Well, you know what? The Merlin had a ton of teething problems. So when you start isolating the Sabre for having teething problems, the Merlin did too, and I really believe the Spitfire did too, and I just don't know about them, so I'm going to go with that line of thought.
Fair enough. The Spitfire is definitely the plane that everyone thinks as the be-all, end-all of World War II warbirds. I know personally when I was 14, I built a Typhoon model, and the thing that I really loved was that big chin intake.
Yeah.
And of course that drew me to the Tempest as well, but just those two aircraft looked to me like a World War II RAF aircraft. They just, with the invasion stripes and all that, they just looked to me like that's what they look like. I mean, if the Spitfire is more of the Greyhound, I think the Typhoon's more of the Bulldog.
Yeah, the Spitfires had grace. They were sleek, light, beautiful, maneuverable. The Hawker fighters, and I'll include the Hurricane in this, they're brutish. They were big beasts, not necessarily the most aerodynamic. They forced their way through the air with sheer power, and they accomplished the task, and they came back. They're just amazing aircraft, but very different in design.
True. It's funny, just as a side note, even the Hawker Hurricanes still had that canopy that had the spars on it. They never did go to a bubble canopy on the Hawker.
No, I saw a picture. I don't know if it was a joke. Somebody drew a picture. It was just a line drawing of a Hawker Hurricane with a sliding hood on it, and it wasn't right. But that's an interesting thing, and people need to know this, is that the Hawker Typhoon was the first aircraft to fly with a sliding hood bubble canopy. Really? So you look at every fighter now, and everybody has them. In the war, everybody followed suit, and they put them on. But it was the Typhoon that should get credit for that.
Even before the Spitfire?
Oh, yeah.
Really?
Yeah, it had that weird little half bubble thing.
Right.
Not a
oh, I see. Yeah, which probably would have provided a lot more visibility for the pilot, full bubble.
Absolutely. And they did, you look at the Seafires and things like that, they ended up with them. The P-47 at the time was a Razorback. They looked super cool. Mm-hmm. But they went to the sliding hood canopy, the Mustang, everybody.
That's true. Yeah, the Curtiss.
Yeah. So, the Typhoon's the coolest kid on the block.
Yeah. Let's head towards a little further down the line where the tail failures they had early on with the Typhoon. What, without getting too into the weeds of it, what was happening and what did they do to finally fix that?
That one's really cool. I did an episode on this, and I enjoy dealing with it because it's such a prevalent issue with the Typhoons that people talk about carbon monoxide and tail failures and just how it killed its pilots, but it's not the case. There were roughly 28 pilots lost. There might have been more because they really don't know. There's accidents that took place that could have been tail failures or carbon monoxide. They're not too sure. So a lot of guys did lose their lives in this. And it took them a long time to figure this out. But that comes down to the learning curve of monocoque structure. And when you look at the failure point on the tail failures for the Typhoon, it was between what they call frame K and L. It's the joint where the back or the empennage, the tail section, attaches to this monocoque section that we're building here. And the design that they used is really unorthodox. And I think a layman could probably look at it and say, that's not a good joint. Not if you're holding the tail on an airplane at 500 miles an hour in a dive. But it was two frames that were placed 2.1 inches apart and just had a strap doubler in between them. There's no continuity of the stringers, no load sharing from front to back other than this little skin strap doubler. So that wasn't the problem, but it was the weak point that the stresses concentrated and failed, and that's where they ripped apart. So it took them until 1943, and they started flying them in 41, so operationally in 42. It took them until 43 to actually identify what was happening and put the proper fixes in, but during that time, they needed to be seen as doing something about the problem. So they were just putting doublers and patches on everything, hoping that they could fix it, and it just wasn't working. It was one pilot survived from a tail failure and actually reported back that there's a vibration. And they went to vibration analysis at the Royal Aircraft Establishment they basically mounted it all on rubber bands and put vibration through the airframe and discovered that there was a node right beside the mass balance in the tail section for the elevator because it's got a remote mass balance. And that node rendered it useless, basically. So they ended up having to do a whole bunch of rebalancing of rebalancing of the flight control system and a bunch of other repairs in there to beef up some of those structural areas before they were actually able to solve the problem. But it never left the thoughts of the pilots. They kept the fish plate repair that they had on it, which again, that does help transfer some of the stringer loads that I was talking about, but it wasn't the fix of the airplane. They kept that on there for comfort for the pilots, I think, but they left that poorly designed transport joint in there.
Now, about that joint, do you think that was part of the design because you mentioned earlier that when they were building the airframe, they did it in, was it 5 sections?
4 sections.
4 sections on the assembly line. Was that part of the design to be able to do it that way? Or like you said, a layman would look at this and go, that's not working. Where did you think this design flaw came from?
It's just a bad design.
Oh.
It wasn't part of the process for doing that. In fact, we haven't recreated that with this. It's one area that's so crucial in the design of this aircraft that we've actually put in a Tempest unit. That joint was actually used in the early Hawker Tempest 5 Series 1s, which is like the first 100 aircraft produced. It used the same transport joint as the Typhoon, but they quickly after that went to a new transport joint that was an extruded angle on the forward and aft monocoque section that were bolted back to back, just tight. The loads transferred great. It was a very, very good design. And that's what we've actually installed on JP843 is the Tempest style transport joint.
Can you explain a little bit? I mean, it's not, you're saying to me, it's not really a monocoque fuselage, but mostly a monocoque fuselage. Can you explain how how that's designed and how that works?
Well, one thing that I do is when I'm actually all of us here for the from the design right through to production for JP843, we use the terminology that Hawker used with their designs because it prevents any kind of confusion. What Hawker used for their design terminology might not be accurate to what we normally use today. So the term monocoque is one of those. And I've had a few people point it out. The structure on the Typhoon, we refer to it as a monocoque, but it is not a monocoque. By definition, a monocoque is basically a stress skin that supports all flight loads. So you wouldn't have all the frames and stringers that are in here in a true monocoque.
Right, like a Formula One car is considered a monocoque because it's the shell of it is the support structure.
Yeah.
I see. So clearly, the Hurricane wouldn't have had that because it was a fabric cover.
Yeah, it was another tubular structure, and kudos to Sydney Cam. And I know people critique the complexity of the mechanically jointed structure in the Hurricane, the Typhoon, and all of the Hawker lines that used it, but it is absolutely beautiful. It's it's unmatched. It's an amazing piece of mechanical engineering.
Further to what we were talking about earlier, the Spitfires get all the glory, but the Hurricane was the workhorse during the Battle of Britain, and I can't remember the numbers, but shot down more enemy aircraft than the Spitfires did, and the Hawker Hurricanes were far outnumbering the Spitfires back then too. So Hawker was not despite having all the issues with the Typhoon, they were not a slack organization. They put together some pretty successful designs over the years.
Oh, absolutely. And every aircraft had its role. I mean, I don't think it's fair really to compare the Spitfire with the Hurricane. They were used in the same role in many cases. But when you look at those numbers, the Hurricane did in fact shoot down more aircraft than the Spitfire during the Battle of Britain. There were more Hurricanes than Spitfires available, and the Hurricanes had a slower speed and often went after the bombers as opposed to the fighters. So there's a lot of different factors at play there, but the Hurricane was a brute. It was used from the beginning to the end of the war in every theater imaginable, and it did its job well. It really stood up to the test of time and battle.
Yeah, you talked to seeing some of the interviews from the old pilots back in the day from World War II. They say you strap on the Spitfire, but you could chuck around the Hurricane.
Oh yeah.
So it's kind of interesting how they use the terminology and how the difference is between the flight models. Back to the Typhoon, another teething problem was carbon monoxide, which is kind of strange considering if you look at the basic design of the aircraft, it's kind of similar to the standard design of the day. Yet for some reason, pilots were dying because egress of carbon monoxide. Can you expound on that a little bit?
A little bit, yeah. I think what they really owed it to was the car door type Hawker Typhoon, the early ones, and carbon monoxide seeping into the car door. But I'm not convinced that was 100%, and I don't think they were either. I know that the pilots had to fly with oxygen right through to the end of the war. I don't know what the technology was for detecting carbon dioxide in the cockpit.
You passed out.
Yeah, you die. So I don't know what they could have done to detect it, but I know everybody is more comfortable with oxygen. When you look at the design of the firewall, there's definitely some issues there. There's a lot of patch plates put on it to try and seal around where the tubular structure went through it. So that's definitely a potential cause for it. But they did do a bunch of modifications to try and reduce that. The sliding hood was a big one. They also put vents on the monocoque section. There's 3 vents that go on it that help basically create a vacuum in flight and extract air from the cockpit. So I don't think we'll be 100% confident until we have this running with the engine and can actually do some testing to see what's happening, if it's happening, and if it is, where it's coming from.
I've always been suspect of that, Ian, because, with the engine running and the spinner going and all the amount of air moving past the fuselage, it leads me to suspect that the carbon monoxide was coming in from some other way. Through the firewall, or it just seemed really strange that it was leaking in from the outside.
It's hard to say. The exhausts are both there, and you've got this massive engine spitting out tons of fuel. I don't know how many cubic feet of air would be pumping out of that every revolution, but it would be pretty significant. And then you have the propeller blowing that backwards towards the cockpit. So, my assumption would be that it has to be something external, like the doors on the car door type, or maybe poor sealing even on the sliding hood if the seals were wearing or anything like that. But yeah, like I say, we just won't know until we're able to test it. We'll do everything that they did, make sure that it's up to the standards that they had, and then try and solve that one and answer the question in a detailed manner.
Right. Something else that's kind of interesting about the Typhoon was it the first aircraft in World War II, well, fighter aircraft, bomber aircraft, to have a retractable tail wheel?
I don't know.
I think it was. I think the Spitz didn't have it, and the Hurricanes didn't have it.
Oh.
My understanding, it was part of the design to make it more slippery.
Interesting. No, I didn't know that. I know they the Tempest ended up with tail wheel doors, and they're looking at putting them on the Typhoon as well. I've even heard reports that when they did tests with the tail door on the Typhoon, the tails started falling off again, but I've got no evidence to support that. So, but yeah, I honestly, since I was a kid, I really haven't looked too much at other aircraft. Hawker stuff is my interest, in the Typhoon specifically. So that's a neat little fact.
Well, I could be wrong, but something we can check out.
Somebody will chime in.
I'm sure. Well, with that, we'll bring to an end another episode of Hawker Typhoon podcast. Thank you, Ian Slater.
Thanks, Fred.
Appreciate that. And our producer, Rob Hunt. If you want to learn more about Hawker Typhoon and JP843, you could go to the website, typhoonlegacy.com. And thank you for joining us.